This is John Black, Super Chemist. If you saw my last video, you'll see that I got some auto parts cleaner and I extracted the toluene out of that. I got about 16 milliliters of pure toluene. Let's see what we get out of this. I'm going to use the same amount, which was about 450 milliliters. So that would be how much is in a can of the auto parts cleaner. This is obviously a big can, a gallon can Crown brush cleaner. I'm going to pour it in there like I am. And I'm basically going to do the same thing as I did last time with the auto parts cleaner. I'm going to put some water in there so it forms two layers. That way I get rid of any of the small polar and non-polar things like ethanol, methanol, acetone. They only have small non-polar parts, but they have a polar part, so it gets sucked into the water. I'm going to shake that up, let it sit for about 20-30 minutes at the very least. The bottom layer is going to be the water. I'm going to drain it out, and hopefully it'll have all the alcohol and polar stuff in it. I'm going to do this a second time. Pour the water in, just a little bit. See, I'm just putting a little in there. There isn't that much polar stuff in there. I'm going to shake it up, let it sit 20-30 minutes. Drain out the bottom layer. Do it a third time. Put a little bit of water in there. Shake it up. Let it sit 20-30 minutes at the very least. Then I'm going to drain that out. This time, though, because I've been putting water in there, I'm going to put some salt water in. That's really polar. Get some of that water out of there. Shake it up. Let it settle out. And I'll drain the bottom layer out. Now all I have is the non-polar stuff on top there. I'm going to drain that out into a container and see how much we got here. Keep in mind we started with 450 milliliters. We're going to end up with about 345 here. So we got rid of 100 milliliters of alcohol and acetone and whatever else was in there that was polar. Now I'm going to get rid of the trace water molecules in there by adding some anhydrous magnesium sulfate, which is just Epsom salt that was dried out. I'm going to let that sit inside there. I'm going to stir it up first for about 15-20 minutes, and then I'm going to let it sit until everything settles down so I can see that it's a nice clear liquid with no particles floating in it. Look how crystal clear that is. That's like water. So the first thing I'm going to want to do is I want to get rid of all the low boiling things. Toluene boils at 110.8 or something like that. Let's just say 111. So I'm going to boil everything out of there lower than that. Okay. This is my apparatus. I got everything, all that non-polar stuff inside there. My heating mantle. You can see I have a bigger X column, goes straight up, 180 degree angle back down, goes to the condenser, and then a smaller round bottom flask. See there, where I'm going to collect everything. I did this at a slow rate. Everything started coming off at 63, just a little bit at 60. Mainly it was coming off around 63. Then it jumped up to 80 for a little bit, 90 for slightly, very, very, very little. As you can see right here, I'm seeing what the stir bar is. It's at 67. Although by the time it gets up the bigger X column, it's cooler. You can see my drip rate. I'm not going, super fast or anything like that. I don't want to get any of my toluene escaping with this. So I do it not as slow as possible, but still slow. You can see I got about that's 100 milliliter round bottom flask. I got about 30 milliliters out of there. So everything that's in that pot now is, because once it went past 90, it shot straight up to 106, and then I turned it off. I moved everything down before it went to 110. And So I got everything out of there except for the toluene and higher boiling point compounds. Now this one I can't put all. I gotta split up the high boiling non-polar stuff, and then you see that separatory funnel or equalizing funnel to the left there. That's my alcohol. I'm going to put some methanol in there, and I'm going to do an azeotropic distillation. Or wait, a 74% methanol, 26% toluene. As you can see over here, this is in this separatory funnel. That's stuff that was left over from the where I cleaned off. You know how I kept dumping the water in? Well, that's the water there. And there is a little bit, you can see there's a top layer there. And so there's obviously some more non-polar stuff in there. Look how I can't get the soap out of there, though. No matter how many times I dump water in and take the water out, it will not get rid of that soap. But watch this. I'm going to dump a little bit of methanol in there. Okay, you can already see how it took that soapy stuff out of the top layer. Now it's all crystal clear like. And there's that little bit. See, I left a little bit at the bottom there, but you can tell all that clear part is stuff that I can also use. You know what I mean? 10-20% of that is toluene. So anyways, here's my drip rate. I did this at a pretty good drip rate. Basically, it shot up to almost 63 right off the bat, and it stayed there the whole time. I didn't let it go up past 64 until the very end, and even then I only let it go up to 65. The azeotrope, I think, was at 64.3 or something like that. And there to the right is my azeotrope. I have the second half. Remember, I couldn't fit everything into that round bottom flask because you got to put so much methanol in. The second half, though, I put the methanol and the azeotrope into the pot all by itself. I didn't need the equalizing funnel. And I'm going to fill it up. And you can see I'm almost done with this second part of it, getting all my azeotrope on the right-hand side there. Yeah, the second half of the azeotropic distillation, I went pretty fast, faster than the first one. Still, I went at a decent rate. I mean, it wasn't too fast. I boiled what was left. When I got done, I boiled what was left in the pot, meaning the high boiling non-polar stuff. And I couldn't get anything to come over until 120 degrees Celsius. So that must be the next thing in there that came over with the methanol. Probably formed an azeotrope with it. So there's the end. There's on my hand. That's the first distillation I did. Has the high boiling point stuff in it. To the left there is the second one where all the high boiling points, and to the right is the azeotropic from both of those. This little flask here was the low boiling stuff I boiled off, which is about 30 milliliters. I'm going to dump everything out and get exact ratios or measurements here. Low boiling point's 29 milliliters to the left, then high boiling point 180 milliliters, and then the azeotrope to the right, which is 420 milliliters. So I'm basically going to do the same thing I did at the beginning. I'm going to put that in a separatory funnel and get all that water or methanol out of there by throwing some water in. It'll form two layers. Here we go. I got the non-polar stuff. Dump some water in it. Shake it up. Let it sit 20-30 minutes. And the top layer will be the toluene. The bottom layer will be the methanol water. Get it out of there. You can see there's still some funk up on that top layer. So I'm going to give it a little swirl here. Get that down to the bottom so it's nice and clean before I get it all out of there. Got to dump some more in there. Form two layers. Shake it up. Let it sit 20-30 minutes. And let it flow out. Get rid of that. Now I'm going to do salt water. Throw some salt water in there. Shake it up. Let it sit 20-30 minutes at least. Yeah, you can see how clear. I actually let that sit for hours to get it like that. Get that bottom layer out. Now I got pure toluene up on top. Let's see how much there is. It's about 95 milliliters there. Now I'm going to throw some magnesium sulfate in there, some Epsom salts anhydrous. Get any water out of there. You can see how crystal clear that is after about 20 minutes of stirring it and letting it sit. Let everything settle out. Now I'm going to take all my toluene, because it's not all toluene. I'm going to distill it. I'm going to use a Vigorex column. You can see I got my heating mantle there, stir bar. That's all my toluene. Goes straight up, comes back down at 180 degree turn through the condenser and down to that little round bottom flask that will collect all the pure toluene. The first couple milliliters I tossed out, or put aside rather, and then pretty much all of it came over from 109 degrees Celsius to 112 degrees Celsius, and then it shot up to 120 after that. And here I'm going to show you. I'm just using the stir bar to turn the stir bar up and down to get this thing to go up and down. But watch this front. It's coming right up there. Now as soon as it hits right here, that's exactly where it should be. And you should have it no further than that. I have it going up because I'm doing the camera, so I went too far. But you want it to just pour in like you're pouring something, just barely pouring it over that neck there. Anyways, by the time I got done with the distillation, I had about 45 milliliters pure toluene. So I lost obviously some because I started out with 95 milliliters. But if you recall, we started out with 450 milliliters and we ended up with 45. You can see to the right, that's a 50 milliliter round bottom flask. It's almost full up, so that's about 45 milliliters. And so that's a 10%. We got MSDS said 20 to 30%. We got 10%, so it's not bad. I did a little summary here. I don't have enough time to read it all, but if you want to press pause and check it out to see how I figured things out, you can. I ended up with 45 milliliters of toluene. That's 10% out of the original 450 I started with. I'm going to see how this goes by not using the azeotropic distillation, and I'll be back in a second to explain what I did. Now, I wanted to see what would happen if I did a regular fractional distillation instead of an azeotropic one. As you can see, I started out doing the same exact things. I got rid of the polar stuff. I distilled off the low boiling stuff. Now, right here in these brackets, that's where it changes. Now, I didn't throw in the methanol. I just kept distilling between 100 and 120 degrees Celsius, and I got 120 milliliters of toluene. Now, you can see right here, I distilled that again between 105 and 115 degrees Celsius, and I got 80 milliliters. I did the same thing basically because one of those, I can't remember which one, if it was the first or second, one of them wasn't a very good distillation, so I did it a second time. Anyways, I took the 80 milliliters down to 60 milliliters. Then I did the same distillation as before with the azeotropic one. I took 109.5 degrees to 112 degrees Celsius to get 45 milliliters. And that's what I got doing it with the azeotrope. 10% yield, so it's the same either way. Remember, science is great.